Alrighty, welcome to Chapter 4, Section 6, called Construct Functions. This is for Math 8. So just a couple of things that you'll see on the screen here. The first thing you should see is a due date. I don't see it on the teacher preview, but you'll see it on your student screen. The second piece here is the attempts. We always have unlimited attempts on the homework, the homework assignments, the quizzes, and the tests. So you can come in and, complete the assignment as many times as you would like. This particular assignment has 4 questions. Kind of just depends on the section there for how many questions there will be. Grading policy is always best score, so whichever attempt is the best one is the one you keep. Partial credit's enabled, so if you answer 1 of 4 questions correctly, you get credit for the 1 question, or however many you answer correctly. So please remember this little tip down here. It says once you start your homework, you must finish it before you can work on anything else. What that means is once I click start, down the bottom right corner here on your screen, you don't see it on mine, but on the student screen you'll see it, there's going to be a submit assignment button. So as soon as you're ready to leave the screen, whether or not you have finished 1 problem or all 4 problems, or if you haven't even started a single problem, you click submit assignment button. It does 2 main things. Number 1, like the last screen said, it stops the whole program from locking you out of all of your other assignments. It assumes that you want this attempt left open if you don't click that button, and it will lock you out of everything. Number 2, it actually affects the gradebook when you click that submit assignment button. So your teacher can actually see what you've been working on and hopefully will make an impact in the gradebook, a positive one. So just always being a good habit, click that button. On the side here, we have explanation, example, and message center. So explanation tells you you're going to lose your question attempt because it's going to give you the solution to this question here, not an example, but this exact one. So you don't get the answer and then get to come type it in. Sorry, that's not how this works. But you can see an example. If you click example, here's an example, something very similar to what we're looking at. So it's going to be that problem type. It'll show you exactly what it wants you to do in this problem type. You can read through the example. Once you're done, you click close. You can open another example if you want to see another one. You can also message your teacher directly from the screen. It attaches a picture, so hey, we know where to come help you. All right, so let's go ahead and take a look at this one. So we've been working in Chapter 4 for a couple weeks now. And so now we're going to look at how to build a function. So scientists are measuring a distant planet's temperature. The graph shows the temperature in Celsius versus the height in kilometers above the planet's surface. So if we think about a planet, and I'm not super great at drawing 3-dimensional figures, but, I kind of did the dotted line backwards, did I? Dotted line should go behind things, because we can't really see that. All right, so we have a planet here. And depending on the height from the surface, so the height from the surface, the higher up we go, the temperature is changing. So this is showing, here we have height, and it's going up from left to right. We started 0, and we're going up to 9 on the chart here, or the graph. And then for temperature, it's going from 0 to 40. So we're also going up on the side on this one. But if you notice, the line is not going up. What we call this is a negative slope because it's going down from left to right. So as the height goes up, the farther away we get from the planet, the colder it actually gets. Because at 0 degrees on the surface, it's 40 degrees Celsius. But at 4 kilometers above the surface, so we're pretend like this is 4 kilometers, that would equal, or not equal, but correspond to 0 degrees Celsius. 0 degrees Celsius. Like that. So right on the planet's surface, if I'm at 4 kilometers, then it would be 40 degrees Celsius. So it's just showing us, the farther away I get from the planet, the colder it's getting. So we can see as one is increasing, the other is decreasing. I have this negative slope. So I want to pay attention to that because we're going to have to answer a question just like that in a minute. So at what height above the planet's surface is the temperature 0 degrees Celsius? So we want it to be here 0 degrees. So we already kind of answered that, right, in my little diagram here. That would be 4 degrees Celsius. So we'll type in 4 kilometers, not 4 degrees Celsius. Jeez Louise. Mixing up my units there. So choose the statement that best describes how the height and temperature are related. So this is that one increases as the other decreases idea. So as the height increases, that's true. The temperature decreases. Ooh, that's also true. So this one definitely works. If we read the next statement, it says as the height increases, the temperature increases. That would mean if they're both increasing, we should have a positive slope, meaning it would go up from left to right. But if it's going down from left to right, that means one is increasing and one is decreasing. All right, so we know that the height is increasing, the temperature is decreasing. At what rate is the temperature decreasing? So now we need to take a look at this and say, how fast is it decreasing? So if we look at, a lot of the time, if you look at 1 on the x-axis, because what we want to do is we want to know what is the ratio of y over x. And if you look at 1, this does actually cross right over one of the grid lines, which is nice. That's what we want to happen. If it was in between, we don't want to estimate. But this does look like when x is 1, y is 30, which means that for every 1 kilometer above the planet, it's going down by 30 degrees. Or it's not going down by 30 degrees, sorry. I'm saying that funny. It went down to 30. We started at 40, though. So if we started at 40 and 0, so we went up 1 degree, now we went down to 30, so it looks like it's going down by 10 degrees. We could also look at this relationship here. We went from 0 to 4, so that's 4 kilometer increase. So we went up 4, that was a change of 4, and we went from 40 to 0, that's a decrease of 40. So I went from 0 to 4, that's why it's an increase. I went from 40 to 0, that's why it's a decrease. Well, if I reduce that, it's negative 10 over 1. So again, I get that 10 degree change. And it's a negative 10 degree change. I don't think I have to put negative in here because it's asking how is it decreasing. So we already know that it's a negative. We just have to type in 10. So we can go ahead and click check here. So this is just another way of looking at slope. And they did the x-intercept instead of the y-intercept. But it's just another way of looking at the pieces of our function. All right, I think we have another one of these guys. Let's see. Okay, and I'm going to change the color because that yellow is kind of a funky color. All right, at a candy factory, a machine is putting candy into a container. The graph shows the amount of candy in pounds in the container versus time. So we have time on the x-axis, and that's going up, and we have amount of candy on the y-axis. And again, it's counting up, but we want to look at the line. It's going up from left to right. So that means it's an increase of both. As time moves on, there's more candy in the bowl, more pounds, or in the container. They didn't say bowl, but same idea. So the first question says, what is the amount of candy in the container at 0 minutes? So if I go to 0 minutes, we want to look at what are we starting with? How much was in the container to start with? Well, it's 40 pounds. So it'd definitely be a big bowl if that was a bowl. So probably something other than a bowl here to hold 40 pounds of candy. So what statement, choose the statement that can best describe the time and amount of candy are related, then fill in the blanks. So remember, time is increasing, amount of candy is increasing. As time moves forward, I'm getting more and more candy here. So they're both increasing. So we want to choose a statement that says that exact thing. So as time increases, the amount of candy in the container decreases, or as time increases, the amount of candy in the container increases. So increase and increase. We want to choose this guy here. And this is at what rate is the amount of candy increasing? So again, just kind of like we did on that last one, I want to look at if I had 40 at 0 minutes, I want to see what am I increasing by to the next minute. So at 1 minute, now I have 160 pounds of candy. If I go to 2 minutes, so 2 minutes here, I have 280 pounds of candy. So we can't really reduce this one, but we can see what is the change. So to get from 40 to 160, I would have had to add 120 pounds. And I'd have to add 1 minute to that, right, to get from 0 to 1. To get from 1 minute to 2 minutes, I'm adding another minute. And to get from 160 to 280, we need another 100, and we need another 20, right? So it's going up by 120 every minute. So that's our slope. So this actually had y-intercept and slope in it. Because remember, our y-intercept is this point where it's intersecting the y-axis. It's also our starting point. That's another big one that I keep talking about in class, if you have me in class. All right, so let's take a look at the next view here. Let's see. So Ryan is printing extra flyers to distribute. The flyers are printed at a constant rate. The table shows the number of flyers he has after different amounts of time. So we have 10, 15, 20, 25, and this is minutes, so it makes sense that it's increasing. Time is generally increasing, right? We don't just have time standing still. So this is going up by 5 minutes each time. And then he had 92 flyers, he had 107 flyers, he had 122 flyers, 137 flyers. So if we look at this, this also is increasing. It's going up. So increase and increase. We have an increase of both. So again, when we describe that, we want to choose as time is increasing, the number of flyers is also increasing. So let's see, we have 8, 7 more, that's 15. Let's see, let's make sure that works. That's 3, 4, 5, yep, 15. So it's 15 flyers every 5 minutes. So this is the Y or the run, sorry, the rise, I said that funny. And this is the X or the run if we're thinking about slope, which I know we've been dealing with slope and y-intercept and all these different pieces for quite a while. We're just kind of putting it now into more real world terms of, what's the context behind them. So now I have 15 flyers in 5 minutes. If I reduce this, they both can divide by 5. I get 3 flyers every minute. We want to reduce it down to a unit rate where I have 1 on the bottom because that's what they're going to want us to answer this question with here. It says, at what rate is the number of flyers? Number of flyers Ryan has increasing. So it's blank flyers per minute. So we just did that. It's 3 flyers per minute. How many flyers did Ryan already have when he started printing? So we need to go back to the beginning. You can do this a couple of different ways. So, and I know the way I did it in class, which I don't need to erase this. I just took the table and I went back to get down to 0 minutes. So with this one, if I had 10 and 92, and I'm adding 5 to go this way, to go back, I'd subtract 5. I want to know what happened 5 minutes ago, or how many flyers did I have 5 minutes ago. So at 10 minutes, if I take 5 away, I'm at 5 minutes. If I take it away, I'm at 0 minutes. This is where we want to be because this is going to be our y-intercept, our starting point at 0 minutes. I want to know how many flyers did I have then. So I can do the same thing. If I'm adding 15 to go this way, I can subtract 15 to go this way, to just go back. So I want to know how many did I have to start with. So I need to make sure, and they don't have the calculator open here, but I know we have calculators available in class if you need them. So you can also just kind of do the long division here, or long division. Jeez Louise, I'm just mixing up all my terms here. You can do the subtraction on paper here. So let's see, we have 5, 6, 7. So that is 77. And then if I subtract another 15, so I'm going to subtract another 15. So that's 2 and that's 6. So 62. So it looks like he had 62 flyers to start with. And then he started making 3 flyers every minute until he got to 137 flyers. All right. Perfect. Let's go ahead and try this last one here. You can also do, and I know we've done this in the past when we had slope and intercept, we can choose one of the points and plug this in to get that starting point. Because this is an X and a Y coordinate. And then we had the slope, we calculated that, that's the increase or decrease per minute. So I can actually show you here, we'll do that one on this one, because that's just another method of looking at this. So we have 620, 560, 500, 440. All right, so we're increasing, again, time, that makes sense. We should probably be increasing in time. The only time that I could think we would be decreasing in time, if it wasn't necessarily referencing time as an element moving forward, but is like a countdown type idea, like there was only so many minutes left on a test or something like that. But I've always seen these ones as time increasing. All right, so this definitely is decreasing. I went from 620 down to 440, so this is definitely going down. So let's see, we had 20, another 40 there, so that's going down by, looks like 60. And then, yep, 60 again to go from there to there, and then another 60. So we're going down 60 every 5 minutes. And I probably should have read this. Sorry, I just kind of started jumping in and doing the slope on this one. So at a factory, workers are draining a large vat containing water. The water is being drained at a constant rate. The table below shows the amount of water in the vat after different amounts of time. So we're going down by 60 liters every 5 minutes. So I want to reduce this because they can both divide by 5. So I'm going to have 1 minute, and if I divide by 60, I get 1 and 12, and that's negative. So it's decreasing by 12 liters every minute. So I can already see it's a decrease. If I were to look at this on a graph, it'd be going downward from left to right. So as time is increasing, the number of liters is decreasing. So again, we want to choose that. If as time is increasing, the amount of water in the vat decreases. And if we read the other one, as time increases, the amount of water in the vat increases. That'd be meaning they're adding water, but they're taking water out. So then we already answered this by simplifying the slope. The liters per minute that are decreasing are 12. I don't have to put the negative because of the word decreasing. It's not going to expect me to put negative there. All right, now how much water was in the vat when the worker started? So again, you can do that same idea and you'd go back. With this one, I'd have to go back 3. So I'd have to subtract or add 60 back to it 3 times. But you can also use y equals mx plus b. So we've practiced this quite a bit in class. Our slope is negative 12. We just found that out. I don't have to put the over 1 there because it really just means negative 12 here. Anything divided by itself or anything divided by 1 is itself. And then what I can do is just pick one of the coordinates. So I'm just going to pick this first one here. This is my x, this is my y. So I'm going to plug these in, and I'm going to have 15 plus b, and then 620 for y, like that. So now I have 15 times 12, and that's 180. So I get negative 180. Sorry, it's negative 12 times 15. So now I'm going to add 180 back. And if you think about what I was saying up here, I'd have to go back 3 times to get to 0 because I'm at 15, and I'd have to subtract 5 3 times to get to 0. And I'd have to add 60 back 3 times. Well, if we think about 180, how many 60s are in there? There are 3 of them. So we're really doing the same thing. We're just doing it in a formula here. So it's not a big deal. Either way, whichever way makes more sense to you. Let's see, we have 6, 7, 8. So we have 800. These guys cancel out because we have a negative and positive. So B, which is our starting point, that's our y-intercept. When we have the y equals mx plus b, b is the y-intercept. So this is our starting point. This is how much water was in the vat when the worker started to drain it. 800. Check. Alrighty, so that was section 6. I will see you in section 7.